everyone. So let me frame this talk a little bit and give some context to it, and then we'll kind of decide how to proceed on the spot. So JavaScript has this feature called generators. And I find it's not super well understood, but it's fascinating. It's really, really useful. In fact, it's not just JavaScript that has it. Most languages have some version of this feature under a whole bunch of different names. So in Python, they tend to be called iterators. In I believe in Ruby, it's like you have enumerable.generate or something like that. In C#, you have IEnumerable, which is kind of sort of the core thing that Link works on, because Joe said y'all are a big .NET town. We can get into all that. There's actually a lot more to it than just Link. So it is a very useful feature, present in most languages, with the exception of Java, though you can still kind of do the concepts the same way. A few years ago, maybe 5-6 years ago, I was on a long car drive. I'm in New Orleans. I was driving from here to Houston, and I was just started really thinking hard about application flow and how we interact with applications, and how we a lot of times have this these little helper functions like throttling and debounce, which do all sorts of things with regards to timing, to make sure that our functions don't fire too often, or they only fire at appropriate amount of times. And I've been studying a little bit functional reactive programming, and also looking into generators. And I really started kind of thinking about it in terms of streams of events, and realized that there is a pretty direct parallel between streams of events, or streams in general, and what you can do with generators. So I decided to take this is just kind of my learning mode. When I'm learning stuff, I just start to play with it, and I start to write code, and start to really test the boundaries. And as I got into it, it turned out that the boundaries were way further along than what I thought. And I ended up generating this kind of micro library. It's a little over 100 lines of code, which I call Gimgen. I created it years ago, and it's super, super weird. But it's weird in a way that I have not seen anywhere, and it is really useful. So I actually did end up creating an NPM package for it very recently. I didn't put it on NPM for a long time, just because it's so weird. I kind of didn't want to encourage people to use it. But at the same time, I kind of would like feedback. And the first and foremost is whether my NPM package worked. I haven't created an NPM package in forever, so I threw it up there. It might not even kind of work. Someone. So the deal with this talk is I can make it kind of as long or as short as we want. In this case, we're going pretty short. So there's different ways we can approach it. Either I can lean heavily into, all right, let's talk about generators and what this feature is, and how you could use it in your JavaScript code, and what it brings to the table. Or I can go jump right into the demo and kind of start showing Gimgen. So my experience is that people generally do want to kind of take a step back and talk about generators a little more. So if that's not the case and you want me to just jump ahead, please tell me in the chat, and we could do that as well. In addition, because kind of how this is structured, I would actually rather everyone kind of understands what I'm talking about. So please go ahead and interrupt me and ask questions. It's fine. We'll figure out the presentation on the fly. It's also a very code-heavy presentation, so I know it's not the best for this type of format, but you'll see me like typing a bunch of code and running code and so on. All right, cool. So yes, ask questions if you have questions. Let's go get to it. This is me. this in me. Got to point that way. I'm CTO at Operation Spark. Operation Spark is a coding bootcamp down in New Orleans. I've also done consulting for many, many, many years. But right now I'm specifically focusing on kind of, we're a good bootcamp. I'll say this, I would put us at one of the top tier ones. We used to be partnered with Hack Reactor and all those big names, but we're different in that we're also nonprofit. We have a specific mission to provide opportunities to underprivileged people and stuff like that. Our program is cheaper than a lot of others. Our program also is largely grant supported. Part of that program is getting people jobs, right? That's the entire point of this. So one of the things that we run at Operation Spark is a dev shop. So this kind of just acknowledges this whole fact where you can't get experience without experience, and the fact that it's really, really, really hard to hire junior people because they don't distinguish themselves from each other at all. They all went to 3-4 month boot camp, or they went to a 4-year degree. They all have kind of the same projects to show. They all have, it's just their knowledge level compared to a senior person is like, ee. So what do you evaluate them on? So we run our dev shop specifically. If you're thinking of hiring people, you can come to us with a project or kind of on a staff augmentation basis. We pick a good grad. We have a conversation. You pick some good 1 or 2 or 3 good grads for you, place them with you. Our rates are very low. We basically take nothing off the top because we're a nonprofit. And that way you get to try out our grads, and then unlike a regular consultancy, if you want to hire them, go ahead. Like that's what we want you to do. We want them to have jobs. So that's the end of my spiel. If you are interested in something like that, please talk to me. Also, if y'all would like, I could always join the Kansas City Slack later on, or Joe can get in touch with me through some of the other Slacks that we're in. All right. So like I said, Gimgen is super weird. And when we get to it, I'll show some of the stuff it does. And, you will either like it and be like, this is super cool, or you'll be like, I hate this, I hate you, I hate everything about it, and that's fine. It is at this point, like both theoretically and technically, it works. I am still not sure about the patterns. But we'll get to that, because we're going to talk about generators first. So, can everyone see the code here? We're good? Do I need a...
It's pretty fuzzy for me.
It's pretty fuzzy. All right. In that case, what I'm going to do is I am going to just full on share my screen. Oh, can I share my screen through the thing?
I think I need to give you that privilege. Sorry, I thought. All right, Kevin, you always have to remind me how to do this. Is there a way to say I can share your screen, or do I just make him a host?
You can make me a host. Well, that should probably work.
Yeah. Okay. You are, but I think then I would lose the ability to record.
Unfortunately, yeah. I can kind of do this, but unfortunately, I can't really make the resolution bigger if it's fuzzy for y'all. I was trying to test it earlier. Still no sharing. Also, hey, this is a React community, so React introduced hooks, it's introducing suspense. React has no problem with weird patterns that shouldn't work, but do.
All right, try it now.
Let's try it now. Ooh, yeah, there we go. Let's do this. Okay.
All right, much better. Thanks.
All right. You can no longer see me. Oh, wait, can you still see me? Oh, y'all can see me because, well, let me switch over to this. So now you can see me and my screen, right?
Yep.
Yep. Okay, cool. Oh, by the way, if anyone has questions, but you're too shy to say them out loud, go ahead and put them in the chat too. That's another thing. All right. Iterators. Iterators are simple. There's literally nothing special to them. It's just a pattern. And the pattern works like this. You have a function. And when you call that function, it's going to return an object. And that object is going to have a next method. That's it. So see, you're calling a function, you're returning an object, and the object has a next method. When you go ahead and call that next method, it's going to return another object, which is going to have a value and a Boolean property called done. And that's it. So here we go. Here we have an iterator defined. It's going to do the first few steps of Fibonacci sequence. I'm going to press run, and there we go. 1, 1, 2, 3, so on. In fact, we can go in here. Can I do this? Put more of them in, and then there we go. Look at them, all those Fibonacci sequence. If you're not familiar with the Fibonacci sequence, have you not been interviewing anywhere at any time? It's a very popular sequence used in job interviews. It's actually a fascinating sequence that a lot of stuff in nature is based on in general. And you've probably seen it in story points where if you do story points where the story where the basic theory is that humans are very good at estimating stuff because of its prevalence in nature on that interval of things that are about 1.6 times bigger than the previous thing. Therefore, Fibonacci sequence follows that Fibonacci sequence because there's something particularly good innate in humans about estimating that like that. This actually means that starting your Fibonacci point estimates at 1 is really dumb. That's the part of Fibonacci sequence that doesn't follow that rule, that proportion rule, like start at 5 or 8 or something. Like, that's when it actually kicks in. But whatever, yeah. All the people that do it between like 1 and 8 are like, that's not the point of this at all. All right, so iterators are simple. Iterators can be iterated, right? So I'm going to hit that, and whoa, there's all our Fibonacci numbers. The first 100 of them. Remember what we did up here. As long as while we if we're over at 100, we're just going to return done. But until then, we're just incrementing and flopping, switching, incrementing, whatever. Okay, so I do like to generally stop here and kind of explain this syntax a little. I don't know if this is a little too simple for this group, but lots of people don't know about the comma operator, which is fine. It's a little confusing in JavaScript, and we probably shouldn't all be overusing it, but you should know about it. And you probably have seen it before in for loops. You just never really thought about it very much. So pretty much everyone knows that you can have the semicolon in JavaScript that terminates a statement. You can kind of sort of do the same thing with the comma operator. What the comma operator does when used like this, notice this is not the same as a comma used in a parameter list. What it's saying is here, there's an expression on this side, then there's a comma, and there's an expression on this side. Same thing as with a semicolon. I'm going to run them all in order. First this one, then this one. But then I'm going to return whatever the last expression returned. So if you've ever done a Lisp, that should be very familiar to you. And if not, it's really just that simple thing. So what we're doing right here is we're just on every trip through the while, we're just calling next, stuffing the result into X. And then as long as that done property is not true, we're going to keep going over and over and over again. You could always implement this a different, more roundabout way while saying while true. Do something like const value comma done equals fib iterator dot next if done return. I don't like that I can't see my cursor. That's weird. Otherwise, console.log value, and then that. And I think if I did this correctly, it'll run and not crash everything, but maybe it won't. Oh, yeah, I did break, not return, because I'm not in a function. There we go. It outputted twice, see, 2. That's how it works. All right, so iterators can be iterated. Here's another thing people don't know about JavaScript very often. JavaScript has symbols. So if you've ever done Ruby, it's got super slick implementation of symbols. In JavaScript, it's not that slick. It's kind of awkward and kludgy, which is why most people don't use it and don't know about it, frankly. Other thing people don't know very often, that symbols can be properties. It can be the key of a property on an object. So if you have a JSON, a JavaScript object, different things that can be keys on that are strings, numbers, and symbols. That actually means that the default TypeScript definitions for that are wrong because they don't take symbols into account. The interesting thing about that is symbols are not JSON serializable. So any properties that have a symbol as a property are just not going to be serialized. There are also certain special symbols defined. And if things are using that property, well, they become cool things you can do. So for example, we can take the symbol.iterator and set that property to that same manual Fibonacci sequence function that we wrote before, which is nothing special. It's just a regular function that happens to return an object with an X, and that happens to return things with a value, and done. Once we set that object to this, we can now use a thing to iterate in a for of loop. Look at that. That means you can make anything in JavaScript iterable just by adding a symbol.iterator property to it. Pretty cool. All sorts of neat, probably you shouldn't do it, but hey, you can, stuff you could do with that. All right, let's take a step back and talk about ducks. If you've ever wondered how, all the Huey, Dewey, and Louie were related. Children, 0. Do I not have that? Children 0 is not iterable. Oh, I forgot how I coded, how I hooked that up. Anyway, you could put whatever you want in there. It'll just work. All right. So long as you know the actual object. I created these slides a long time ago. Anyway, iterators can be used to flatten. That's pretty cool. Now here's the deal with generators. They're that exact same thing, except a much, much simpler syntax for it. So this type of thing on the left could do that all the time and everywhere. You could do that in Java. Languages that have iterators have this additional syntax. In JavaScript, it happens whenever you do function star. And with that, you get a function that can essentially be called multiple times, sort of. And every time you call the function, it's going to start off at a different place before returning something, before yielding back an object, which is kind of like a return. So multiple returns, because multiple returns are basically an enumeration. It's a stream of things. So so we're going to start with 1 and 1, and we're going to yield each of those back. And then for the next 98 times, we're just going to push the second one into the first one. The first one's going to be the addition of the first plus second, and then we're going to yield the new thing back. And when we run that, great. There's our Fibonacci sequence again. Once you get used to this yield syntax, it's way the frick simpler than this other stuff. because this Fibonacci is about the simplest situation that you get with it. Let's move on. This is something that's pretty useful to understand. Iterators can be infinite. They don't actually have to stop anywhere. It's just this function that you have a next method on. And then that returns a value and a done, right? No one says that the done ever has to equal true. That's not part of the spec. It could always be false. So for example, you can see right here on the left-hand side, I wrote my manual Fibonacci. It's the same thing as before. I just don't have that if statement at the beginning, which stops it after the first 100. Instead, I rely on people calling it correctly, and they're going to iterate it 100 times. And when I do that, great, it's going to give us the 101st value, right? Again, generators are the same type, are the same concept, just written in a simpler way. Here we go, while true. And then inside of it, you're yielding. That means we don't have a condition where we end. You could run that, get the exact same thing, clear that, prove to you that we do. There you go. Note that this is really interesting. In normal programming, in normal flow control, you never have a situation where while true is particularly useful. Maybe if there's some like really, really complex looping thing, an unlooping thing, but usually not even that. But if a while true with a yield inside of it is perfectly normal, because basically you're just saying, generate this stream. The person who's going to call it is going to be in charge of deciding when it's done. So long as they never stick it in a for of, which actually will try to iterate it forever, we're all good. So that's a neat little thing, but how is infinity actually useful there? Well, you can do all sorts of neat stuff with that. Oh, by the way, here's flattening ducts with generators. Remember I said it's simpler? It's much, much simpler. I don't need a stack. In fact, the call stack is already a stack, right? When we implement the stack, we're just kind of implementing the call stack within the call stack. So just let it do its thing. Remember I told you it's so much simpler? It's so much simpler. So there you go, run it. Just do that. Hey, we have a generator, right? They'll go through all our children. So this was kind of the observation that I kind of jumped to. We have this concept in functional reactive programming of streams of data. Right? Well, a generator is a stream. It's a stream that you pull from, right? So for example, here is a function where we're going to be generating random numbers, but each random number is going to be higher than the last one, right? So, and then we're just going to go through it and increment it 10 times. Cool, right? So if you, I don't know, need to generate, this isn't a good way to generate database IDs, but if you did, and you kind of didn't want them to be specific, but you wanted each one to be larger than the previous one, like kind of like auto incrementing, this type of thing would work. Again, because it's infinite, that means we're not actually limited to just 10 or whatever. We can go ahead and do that. In fact, we can do, because it's just this, we can do whatever, right? We can multiply that by 2 as we go. There we go. All sorts of cool stuff you can do with that. So this, hopefully you see that and kind of start something tingling and like, okay, maybe this is kind of useful. And here's the interesting thing. The person that's calling your function gets to choose how to enumerate iterators, right? So I'm gonna create a function that's gonna log and take from an iterator every this many milliseconds. So we're gonna create our iterator, and then basically every, let's say 500 milliseconds. Actually, it is 500 milliseconds. We're going to log the next value, and then we're gonna wait 500 milliseconds until trying it again and again and again and again and again, and we're gonna keep going. So I'm gonna click run, and there we go. Every 500 milliseconds, we get a new number that's random, but incrementing. Okay? And we just keep going with that. And let me refresh the page so that stops. Great. Not what I wanted. Not what I wanted. Okay. We have promises for this sort of thing, which can make it a little simpler. So let's go ahead and create our delayed incrementing randoms function. So we're now going to go ahead and basically do kind of a similar thing, except for our generator right here is going to return back a promise. And every single time it's going to resolve in 300 milliseconds. And then we're going to create this little run async function, which basically says, all right, whenever you call next, assume we're going to get a generator, right? A promise back. Before you call the next value after that, just wait until that promise resolves. And there we go. We can do that. And now we kind of, we're playing around where this logic goes. But this is interesting because it means the generator code itself gets to determine the timing of how it's called. Now this is really, really, really close to streams. In fact, it's identical to the concept of streams, with the exception that some stream implementations have this like concept of backflow, which we don't have, but it's not usually even used when people talk about streams. All right, I'm going to refresh that. And of course, we can go ahead and use this with async. I wrote this, by the way. I noticed that I'm not using async await here. We'll get to that. But if you want to have an async function, like async existed in JavaScript before the async keyword. You just did this one-liner and then run async helper from above, which is 3 lines, right? And now you could do stuff like this. Yay! That looks exactly like async await, except we have an async function and yield. So, you know, clearly async and await keywords were such a big breakthrough because they added the ability for us to do this thing on the right instead of this thing on the left. I was actually very much campaigning against it because we had the ability to do this stuff already. Why add more keywords to the language? That battle unfortunately got lost. It also makes things much harder for parsers. All right. So I'm done being snarky about async await. I use it now too. All right. I mentioned functional and reactive programming a couple times. This is the requisite bubble chart you have to show every time you talk about it, or else they throw you in functional reactive programming jail. The basic idea is that you picture a stream of events as something you can manipulate. So here's a stream of maybe clicks on the page, right? You're gonna do something to throttle those clicks. So now that's basically a grouping operation, right? Every click that happens within 250 milliseconds of another one gets grouped into one big group. And then now that we have groups, we can go ahead and map over those. So now we just know how many clicks happen on those 250 millisecond intervals. And then we can filter that as well. So now you're going like, all right, so there's really 2 instances of clicks where more than 2 clicks happen 250 milliseconds apart, sort of. So having shown that generators and streams and thereby functional reactive programming are kind of equivalent, can we do this to build upon like, for example, implementing debounce? So if you're not familiar with debouncing, the way it works is you're gonna, for example, wait for a button to click, and then sometime after it, you're gonna click that it stopped. But if I'm sitting there mashing the button, you're not gonna log anything. You're gonna wait until I stop mashing the button, and then you're gonna log out. right? So here we go. I'm going to start mashing, 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 mashing. Done. 2, 3. There you go. So here's how you're going to do it. You wait for a button click. You start a timer. And then depending on whether the timer ran out first or whether another click happened against, you do different things. So how is it implemented like this? It's actually not terribly difficult to implement, right? Because we have our current timeout that we can set timeout, and basically every time through there, every time you click, you have to clear timeout. This line 4 is actually not even necessary for this to work. So it's not terrible, sorry. But a generic debounce is kind of complex. Here's an example. There's a lot going on there. You ever tried to implement a generic debouncing or throttling method, you know this pain. By the way, if you haven't tried to implement them, you totally should try to implement them because it's a really, really good exercise to get your mind around it. So again, do the concepts in Gimgen kind of help with that and try to make it straightforward. And my argument is that it does. So here's the exact same thing with Gimgen loaded in, clicking, 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 clicking. I'm going to stop clicking, and there you go. Great. Here's what it looks like. We're going to have our run Gimgen function. We're going to pass a generator in, and then we're going to build up a bunch of stuff that we're interested in. We're going to be interested in a timeout of, in this case, 2 seconds, right? We're going to be interested in the click event on this button. Great. And now we're going to be interested in either whether the clock ticks, or the button clicks next. So, and now we're going to loop forever. So while it's true, we're going to wait for that first click. Okay. So none of this starts until that first click. And then we're going to wait until either the next click or the clock to tick. And if the next thing that happened was a click, then we're just going to stay in the state. We're going to chill out in here. We're not going to do anything there. But once the next thing that happens is not a click, so a tick, then we're going to go ahead and log some stuff out. 1, 2, 3, there you go. It's really interesting that, you know, again, we're doing while true, or while with a yield inside of it, and then nothing in the body because there's nothing to do because we just need to wait for a while. And the interesting thing is none of this works on like a timer that's constantly checking the stuff behind the scenes. The trick is all that it's just, that's how while true work interacts with generators and promises internally. So I'll talk a little bit about how it's implemented. But you get some really weird primitives that kind of get really interesting to think and reason about. So is this the same thing? I think this is the same thing. 1, 2, 3. Yeah, but it's just kind of rewritten a different way. So instead of that weird while thing, you can do a while true inside of a while true, which makes sense because you have this statement, you have this thing that you're watching the button for, which is anytime this happens. But then within it, you have another state machine that's basically saying, okay, well, once I have been clicked once, as long as the next thing that's happening is still a click, I'm going to just stay in that state machine. So that's really interesting. You don't get to use break very often, right? You can take this sort of same stuff and implement it with that. All right, blah, 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 blah. So that there are more interesting demos I can show you. All right. So let's look at some cool stuff with this. Well, actually, let me take a minute and explain how this works, because it's not a lot of code. It really, really isn't. In fact, if I can show you the code, it is this. 172 lines, a good chunk of it, documentations. And again, there's no timers or anything behind that. It all works on the on this kind of concept of a signal. What is the signal? It is literally just something that has a create promise function. And when you call that, it's going to return a promise. As long as you're yielding back signals, this will just work. So I created a couple of useful signals internally just to get people started. But really, as long as what you're passing back is this, doesn't matter. It'll work. So let's watch some demos that are kind of interesting. So here's a notification system, something you might have to do. So we're gonna, here's the basic idea. We want the notification to show, we want it to pop up. And then as long as you and if you press it multiple times, send more messages, they will stack up together. But then you want to be hover over, you want them to fade out after a while, unless you hover over them, in which case you want them to stay there and only fade out after you stop hovering over them. So let's do that. So, okay, there's some notifications. We're gonna, oh, wait, don't fade out. Don't fade out. Hold on, there we go. No, don't fade out right there. I want you to stay. I'm gonna hover over it. The other ones will fade out. You know, there we go. So, and then once they're all gone once they fade out entirely. Pretty cool. Let's see, my mouse is moving over there, nothing's happening. Pretty cool stuff. So how do you implement that with Gimgen? Well, here it's basically this. And once you learn to read it, this is actually saying exactly what I just told you. So we're creating a list item, and its message, and we're appending it to the notifications area. Things we care about are what the mouse move signal, mouse over signal. It's just the DOM events, right? Wrapped up in a promise, in a function that produces a promise. So basically create a promise that will resolve next time you mouse over this element. Create a promise that will resolve next time you mouse move over this element. And then next time it's called, when create promise is called again, it's just going to be next time. Let me know. And then we're going to define it as an interaction as either of these two events. So we just create a notification, we add it up here, and then what are we going to do? We're going to remove our hidden class to it so it can appear. And then basically, we're going to wait either for an interaction or a timeout of 3 seconds. And as long as they're interacting, so the thing is not a timeout of 3 seconds, we're going to stay in that state. It's not hidden at all. Oh, great. It's in there. Once they haven't interacted for 3 seconds, we're going to add a hidden class to it. Okay, that will start it fading out. Now they have a chance to either interact with it or let another 2 seconds expire. If the 2 seconds expires, then great, we're done. We're going to remove that element. Otherwise, we're going to re-enter the loop. And again, we're going to remove that hidden class, and someone can start interacting with it again. That's pretty neat stuff. And if you've ever had to implement that, this being the core of it is super duper powerful. Also, again, when do you ever get to use a do? That's crazy. Let's do something a little more interesting. Here's a drag and drop with all sorts of interactions. Ooh, when I go over that one, it turns orange, and that one starts wiggling. And then when I go over that one, we're doing that and there. Okay. Now this is a little more complex. I mean, you have to do like all the helper functions for the math. But we're basically able to model every single one of these interactions as a state machine. So here we go, the not dragging state. That means you're just waiting for a mouse down on the target, right? That mouse down signal, right? You're gonna make sure that the position is fixed. You're gonna go ahead and move it over to however much your target, to wherever it needs to be. And then basically as we're dragging, so now we enter the dragging state. And as we're in that state, we're just doing the calculation. If it's overlapping with the other stuff, well, then we enter either the dragging state, or the dragging over state. Really weird stuff. You're not going to be able to grok it that quickly, but it's really cool. Here's a full game of Pong with it that what are the keys? OP. There we go. Hold on. Come on. Yeah, there we go. A full game of Pong implemented with it. It's not, the simplest, but again, this is the core. This is the core of actually rendering what's going on into the screen. Here's the paddle control. Just kind of waiting for key down or key up and doing the right thing. And then the ball movement is just its own state machine. It's doing stuff. Pretty neat. In fact, you could do things like this. So if you notice, there's a score in the upper right-hand corner. The longer I spend over it, the more it stands. And basically, this thing just tries to run away from me. And I'm trying to get as high a score as possible. What's the source code on this one? If I remember correctly, it's actually really straightforward. Right here. Well, this is the score tracking one. Then there's the box moving one. Notice that this is what do we have here? If you've done a language with coroutines, that's what this is. We've essentially created coroutines. So again, these are functions that are running, that are doing these things independently, but in a very predictable order. There's not a timer running behind the back or something behind the scenes that's doing scheduling or anything like that. It's just everything's in a predictable order, but you still get to break things out and reason about them individually. I mean, heck, if you go all the way in with this, you could even do actors. So here's a bunch of balls. They're trying to they're going to clump together as they hit each other, because I coded some of the bouncing code wrong, and I really liked the effect that generated. But look at that. That's pretty cool, right? And again, it all comes from the fact that here's the bouncer. Here's all it is, and most of this code is just the math on how do you count if a ball hits another ball. Right? So it's interesting stuff. I don't really know what I have here. I think it can be useful. I've never seen something like this in another language, so I have a hard time understanding what levers I should move and how much I should push with it. But it's really cool, and once you get your head around it, and it's really not that hard to get your head around, you could get to use some really interesting programming constructs and do some really interesting things in a very simple manner. All right, so it's 12:50. I'm sorry I went about 10 minutes longer than I intended to. Does anybody have any questions they want to ask? Talk about.
How would you say this is different from like RxJS?
So RxJS, yes, okay. RxJS, at the time, I was looking at Bacon a lot. But yes, it's different from both of those in that both of those kind of have their own language you have to learn. Like you can't use math. Like if you're looping over things, you have to use their construct. You can't just use a for loop. With this, you can. You get to use all the base level language constructs without having to have the library re-implement them for you, which is how it happens to be under 170 lines of code. But yeah, there is definitely some parallels in terms of what you can do. But yeah, if anyone wants to take a look at it, and Toga Kangaroo / Gimgen, actually, if you go to georgemaurer.net and my about page on here, you can find it on here as well. So there's that. And if you want to watch this talk again, I've got a video from another one that I did, which is a little different, with a little bit of a different concentration. All right. Anything else anyone wants to ask about, talk about? All right.
Cool. All right.
Yeah.
Well, thanks, George. We appreciate it.
Yeah.
And thanks everyone for coming. And we'll see you all in January. Have a good rest of the year.